Hello, Assalamualaikum. My name is Izzat Azra binti Ahmad Sirfan. I'm from Z4EM 1103E and my matrix number is 2019, 211 and 798. In this video, I'm going to conduct an experiment called crank and slider mechanism. So, let's go. First thing first, measure the length of both crank and connecting rod. Choose the desired connecting rod and place it to the crank holder and the slider holder. Make sure the crank and slider system is moving correctly. Crank will experience a rotational above a fixed axis moves, while the slider at the end of the system which has a translational motion, and the connecting rod that connects the two components moves in general plane motion. Record the initial position of the connecting rod at the slider. Slowly rotate the crank for every 30-degree increment. Take the reading up to 360 degrees. Repeat the experiment using different values of crank radius and connecting rod length. Explain how a crank and slider system works. This system works as a combination of three parts, and each of them has three types of different motion. The crank experiences a rotational about a fixed axis, and the slider system has a translational motion. Then the connecting rod that connects the two slides and cranks is in general plane motion. Compare and discuss the results from the theoretical and experimental tables. From the result data for the theoretical and experimental tables, for the displacement of 460 mm, connection rod length are not having much difference but still not accurate enough. The percent error is about 0.5%, but the radius for the 25 mm. The theoretical and experiments get the same value for the displacement. Give your comment or suggest at least 4 cases of errors that may affect the results of the experiment. Firstly, the crank and slider system is not moving correctly. Causes the movement of the translational at slider, rotation of fixed point at crank, and general plane motion at connecting rod are not in a planar kinematic motion. Secondly, there may be due to the zero error, such as the 0 degree at the protector are not exactly start from 0. Next, the crank and connecting rods are not measured properly, such as the eyes are not perpendicular to the measurement scale, and it results in an accurate value of displacement. Lastly, the crank is not rotated properly, causing the rotation to measure the degree to be in an unstable position. List some of the practical applications of a crank and slider mechanism. Some practical applications such as piston used in internal combustion engines. The input linear motion and force from the piston is converted to rotary motion and force in the crankshaft. Kinetic energy of the rotating crankshaft lift the piston back to the top of the cylinder, resulting in a reciprocating motion in a piston. Next is bicycle crank. Force is applied to the pedals attached to the crank in order to apply torque to the center shaft and sprocket attached to it. In conclusion, to study about the planar kinematic motion and to study the effect of change in the crank radius and correcting rod length are achieved. There are three types of motions of rigid bodies such as translational motion, rotating about a fixed axis, and general plane motion. And all of them are applied in a crank and slider mechanism. The bigger radius of the crank will produce a larger displacement of the connecting rod. One of the safety precautions in the experiment is to make sure that the crank and the slider system is moving correctly. So the motion of the translational, rotation at the fixed axis, and general plane motion are present in the system. One of the improvements that can be improved in this experiment is the tree length of the connecting rod should be have a wide difference of the length between them. So the effect of the change in the connecting rod length can be seen more clearly. So that's all for me. Thank you.